Welcome back to geometry. All right, ladies and gentlemen, for today's lesson, you are going to need your note packets. You're going to need a calculator. You're going to need a writing utensil and possibly a few highlighters to help you out along the way. All right, today we're going to be taking a look at your day 3 notes. Our goal for today, our geometry goal, given a circle with chords, tangents, and secants that form angles, you will be able to identify the angle, determine a formula to use, and find the missing measurements. So that is our goal today, to identify the angles, determine a formula, and find measurements. So let's go ahead and start by let's figure out what are those angles and what are their formulas. So if we take a look here, we're going to actually work with 4 new angles today. All right, the first is going to be an angle formed by intersecting chords. So if I have 2 chords that intersect, and I want to find the measure of the angle that is formed. Now if I take a look here, we're going to find the measure of angle 1. Now the vertex of this angle, is that vertex on the center? No, so it is not a central angle. Now is this vertex on the edge of the circle? Nope, so it is not an inscribed angle either. So this is just an angle that's kind of floating around the inside of the circle. It's not on it, it's not on the center. So if we take a look here, this angle 1, well, isn't it also a vertical angle to this over here? So couldn't this also be angle 1? Well, yeah. Well, let's take a look then. So far, everything we've done in this unit has been connecting angles to their arcs. So if I take a look at this angle 1, it goes with this arc here. And then if I take a look at the other angle 1, it goes with a much smaller arc. So to find the measure of angle 1, what we're going to do is we're going to take the average of both of those arcs, and that will give you the measure of angle 1. So here we go. The measure of angle 1 is equal to the big arc. Oops, sorry, not the big arc, but we're just going to call it just an arc plus arc all over 2, or you could say 1/2 arc plus arc. So 1/2 arc plus arc, so the average. So you add them and then divide by 2. Now if we take a look at our next example, we have a secant and a secant. So together these 2 secants are forming angle A here. So let's figure out. So we're going to try to find the measure of angle A. Now if I look at angle A and I were to highlight it, this is kind of like a little bit of a spotlight. So it's shining down on this circle. So what we want to do is look to see, well, is it shining, or is this angle including just one arc, or are there multiple arcs here? And if I take a look here, we've got a little arc and we have a big arc. So it's actually shining on 2 arcs. We're going to call that big and small. So this time, to find the measure of angle A, and angle A is outside of the circle, we're going to take 1/2 of the big arc minus the small arc. And that's how you find the measure of angle A. Now, if I take a look at the third example, we have an angle formed by a secant and a tangent. So here is my secant. A secant starts outside of a circle and goes all the way through. And a tangent, it just touches the surface there. So there's my point of tangency at D. So then let's take a look here. So inside of this angle, do we have 1 arc or 2 arcs? Well, there's actually 2 arcs because D is a point on the circle. So once again, we have a big arc and we have a small arc. And we're going to actually use the same formula we did up above. So the measure of angle A is equal to 1/2 the big arc minus the small arc. Okay, our last example. We have an angle formed by 2 tangents. So if I take a look here, I have tangent BA and tangent AC. Now if I take a look and I were to shade in this angle, well, it actually ends up shading in the entire circle. But let's be very careful here. Is there 1 arc or 2 arcs that are shaded? And there's actually 2 arcs. So B and C are your points of tangency. So this would be your big arc and this would be your small arc. So once again, the measure of angle A is equal to 1/2 the big arc minus the small arc. All right, so let's take a look at some comparisons and some contrasts between our angle formulas today. So if we take a look at the first one, our angle is inside of the circle. When your angle's inside of the circle, the angle is 1/2 arc plus arc. Now if we take a look at the next three examples, angle outside, angle outside, angle outside of the circle, and if you look at all three of their formulas, they are identical. It is 1/2 big minus small. All right, so let's go ahead. We're going to practice a few examples together, and then I'm going to have you pause the video and try a few on your own. So we take a look here at number 1. It says find the measure of the angle or the arc denoted as x. So if I take a look at number 1, x is the angle. So I'm trying to find that angle x. Now if I look carefully, angle x, is it inside the circle or outside the circle? It is outside the circle, so I know angle x is going to be equal to 1/2 the big arc minus the small arc. So let's go ahead and take a look. So I'm looking at what's inside of that angle. So right away I can see my big arc is 100, but we don't know what the small arc is, but it's pretty easy for us to tell what that is because a circle has 360 degrees. In the circle so far we've used 120, we've used 100, and we have used 90, so there are 50 degrees left over for that small arc. So now we can go ahead and just plug in our values. So 100 minus 50. So 100 minus 50 is 50. Half of 50, angle x, is going to be equal to 25 degrees, and we have got it. Okay, let's take a look at the second example. So here we're going to find angle x. So here's angle x, but wait a second. Is this angle inside or outside of the circle? This time it's inside of the circle, and that angle is not on the center. So this is what we would call an angle formed by two intersecting chords. So that means if this is angle x, its vertical angle is also angle x. So really I have to use this and this angle because they're both angle x. And we're going to use our formula. Angle x equals 1/2 arc plus arc. And for this case, we actually have both of those arcs, so this one's pretty easy. All we have to do is plug those in. 98 plus 82. We add them together, we divide by 2, and angle x is equal to 90 degrees. All right, let's go ahead and take a look now at number 3 here. So this time we want to find x, and x is an arc. Okay, but in order to find the arc, we have to look at the angle that creates that arc. And the angle that's creating that arc is the 100-degree angle. So I'm going to go ahead and shade that in. So I know my formula here that I'm going to use is the angle equals 1/2 the big arc minus the small arc. So let's go ahead. We're going to fill in everything that we know. I know that the angle is equal to 100 degrees. So I put 100 underneath the angle. Is equal to 1/2. Now my big arc here is 250 degrees. And the small arc, well, that's my x value. So I'm going to subtract x. So now all we have to do is solve for x. So to solve for x, the first thing I'm going to do is multiply both sides by 2. Because then the 1/2 and the 2 are going to cancel. And now I'm going to get 200 is equal to 250 minus x. So then I can subtract 250. I get negative 50 equals negative x, which meant divide by a -1, and x is equal to 50 degrees. So that missing arc here would be 50 degrees. All right, let's take a look then at example number 4 here. So if I take a look, my missing x is an arc. All right, so if I take a look, I do want to see, well, what angle goes with that arc? Well, this is going to be the angle that goes with that arc. I know that that angle is going to be 160 because it is vertical. But not only is that 160, but so is this one. So this is going to be my angle formed by two chords. So angle equals 1/2 arc plus arc. So let's fill in everything that we know. I know that the angle formula is, or the angle is 160. Then we do 1/2. The first arc is x plus the second arc is 240. Now we just have to solve for x. So I'm going to multiply both sides by 2. So that means that the 1/2 and the 2 are going to cancel. And I'm just doing that instead of distributing. And that's going to leave me with 320 is equal to x plus 240. I subtract 240. All right, and we are going to end up with x equals 80 degrees. All right, what I'm going to have you do then is let's go ahead, flip the page over. There are a couple more examples on the back. I'd like you to go ahead, pause the video, and let's try these 6 examples. Let's regroup in about 5 minutes. All right, let's go ahead and take a look here. So did we get 115, 30, 132? And then if we go down to the bottom then, we get 72.5, 20, and 101. All right, we're going to keep moving on then. So number 3 we're going to skip. Let's take a look here at number 4. So we have intersecting tangents MH and MA are drawn from external point M in such a way that the minor to major arc create a 2:7 ratio. Find the measure of the angle formed at the intersection of these two tangents. So let's start by drawing a picture. So we have a circle and we have 2 intersecting tangents. So here's a tangent, here's another tangent. We want them to intersect. So they're going to intersect right here. The point they have in common is M. So then this would be A, and this down here would be H. Now they intersect to create a 2:7 ratio. So that means this is 2x and this is 7x. So before we can find the measure of the angle, we have to find the measure of both of their arcs. But we know that a full circle has 360 degrees. If we break it into a 7:2 ratio, we're breaking it into 9 parts. So 360 divided by 9 is 40. So 7 times 40, our major arc then, is 280 degrees, and our minor arc then would be 80 degrees. And from here now we can solve our angle. So the measure of angle M is going to be 1/2 the big arc minus the little arc. So 280 minus 80 is 200. Half of that would then give us 100 degrees. All right, so I've got one final question for us to try together, and that is going to be example number 5. So if we take a look here, we're given a bunch of information. So what I'd like you to do right now is take a moment, pause the video, and I'd like you to fill in as much as you can. So let's go ahead and give yourselves 1 minute. Okay, so this is the information that's given to us. So I need to find, in order to find the measure of angle F, okay, we first need to be able to find out, well, what are going to be all of these arcs? Well, I have 3x, 12x, 5x. If this is a central angle, its arc is equal to it, so this is 67. But I'm still missing arc GD. But that's okay, I can find that because if I look from G to E, that goes with this 69-degree angle, which is an inscribed angle. So I know that 69 times 2, this entire arc from G to E is going to be 138 degrees, but I already used 67 for DE, so I'm going to subtract off 67, and this arc here is going to be 71 degrees. Okay, so now I have the whole circle. So I have 5x, 12x, 3x, 67, and 71. So what we can do is add all of those together, set them equal to 360, and then I can find the value of x. Okay, so let's go ahead and we solve for x. We're going to get x equals 11.1, and then I can plug that in for my x values. Okay, so 5x, or actually I don't need to plug it in for all, because if I'm solving for the measure of angle F, all I need are the arcs that are inside of this angle. And I know those arcs are going to be 67 and 12x. The 12x is going to be 133.2. So now I can go ahead and plug it into my formula. Angle F is equal to 1/2 133.2 minus 67, which gives us 33.1 degrees. All right, go ahead, try the last example on your own, and the sub is going to have the solution.